In this lesson, we will learn how to solve a system of linear equations using Gauss-Jordan elimination. So to do this, we first write the corresponding augmented matrix of the given system here. And to write that, we will collect all the coefficients of x, and that would constitute the first column. So we have, for the first one, we have 2, and then 1, then -1. Now for the second column, we will collect all the coefficients of the y variable. So we have 3, -2, and then 1. Now for the third column, we will collect all the coefficients of the z variable, and that would be the entries for the third column. So you have 4, 1, -2. Then you draw the bar line and then list down all the constants. So you have 12, 0, -1. Now, so to do the Gauss-Jordan elimination method, our goal is to be able to come up with the equivalent reduced row echelon form of the augmented matrix here. That is the matrix of the form 1, 1, 1 on the main diagonal and zeros on all other entries. So we want to find the reduced row echelon form of the given augmented matrix here. And we do that by series of row operations. Now, to systematically do that, our goal is to make the first entry here, the first row, first column entry equal to 1, and the rest below it is 0. Okay? Now, since this is already equal to 1, maybe the first step is to just interchange the two rows here. So interchange row 1 and row 2. Then we have this new augmented matrix. 1, -2, 1, 0, 2, 3, 4, 12, -1, 1, -2, -1. Now the next goal is to make this equal to 0. Because again, we want this 1 and the rest below it are all zeros. So we first start at the bottom. So you want this to be equal to 0. Now you think of row operations so that this will become 0. Now, upon looking at this, if you add row 1 and row 3, that would give this entry here be equal to 0. And so the next step is to change R3 by adding R1 and R3. So you add R1 and R3, you get 1, -2. So you just copy the rows because we are changing R3. So you just copy row 1 and row 2. So you have 2, 3, 4, 12. And then for row 3, you're going to replace that by the sum of row 1 and row 3. So you add this to 1 and -1. If you add them, that's equal to 0. And that's what we wanted. And then add this to, you get -1. 1 plus -2 is -1. And then 0 plus -1 is -1. So then the next step is to make this all +1. We obtain that by replacing our row 3 here by the negative of row 3. In other words, you multiply row 3 by -1. So again, you just copy all the rows that you did not do anything. So you have 2, 3, 4, 12. Then you multiply -1 to row 3. So that's 0, 1, 1, 1. Then next, we want to obtain a 0 here. So we want this to be equal to 0. Now to do that, we can add. So we can add twice the first row, or the negative 2 times the first row, and added to the second row. That means we're going to replace our R2 by the sum of twice the first row, or in other words, we can do R2 plus or minus 2 times R1. So in that way, so if you multiply this by negative 2 and then added it to 2, you get 0 on the entry here. So you copy 1, negative 2, 1, the first row, copy the first row. Now on the second row, you multiply this by 2, the first row, and then subtract it from the second row. You get 0. And then you do the same thing here. You multiply this by negative 2 and then add it to row 2. So negative 2 times negative 2 is positive 4. You add it to row 2, it's 7. Negative 2 times 1 is negative 2. Added to 4 is 2. And then negative 2 times 0 added to 12 is still 12. Then you copy the third row, 0, 1, 1, 1. Now the next goal is to make this equal to 1. That could be obtained by replacing R2 by, you multiply 6 to row 3 and then subtract that from R2. So R2 minus 6 times row 3. So copy row 1, 1, negative 2, 1, 0. So copy the first row here. And then now you replace the second row by this. So it is, you multiply this by negative 6, or you multiply this by 6 and then add, and then subtract it from 7. So 7 minus 6 is 1. So you copy this and then that's 1. And then you multiply this by 6 and then you subtract 2 minus 6. So 2 minus 6 is negative 4. Multiply this by 6, subtract it from 12, that's equal to 6. And then you copy the third row, 0, 1, 1, 1. Next, we want this to be equal to 0. Now, how do you make this equal to 0? You can obtain that by subtracting these two rows here. So you're going to replace R3 by R3 minus R2. So you have 1, negative 2, 1, 0, 0, 1, negative 4, 6. Now your row 3, again you just subtract this 2. So 0 minus 0, that's still 0. Now 1 minus 1 is 0. Negative 4, oh, it's R3. So negative 1 minus negative 4. So again, it's R3 minus R2. So row 3 minus row 2. So 1 minus negative 4 is positive 5. And then 1 minus 6 is negative 5. Then the next goal is to make this equal to 1. So to make this equal to 1, you just replace R3 by 1/5. So you multiply this by 1/5, 1/5 of R3. So all the entries in R3 will be multiplied by 1/5. So you copy 1, negative 2, 1, 0, 0, 1, negative 4, 6, 0, 0, then divide this by 5, multiply this by 1/5, that's equal to 1. And then negative 5 times, or divided by 5 is negative 1. So now the main diagonal are all equal to 1. Then the next step is to make each of the zeros. So you begin from here. So starting here, you go up. So you make this 0. then this 0, and then this one 0. Okay, so now how do you make this equal to 0? You can obtain that by multiplying R3 by 4 and then add it to row 2. So row 2, you want that to be 0. So what you would do is you would add 4 times row 3. So if I multiply this by 4 and add it here, I obtain 0. So copy the first row. And then I'll do this. For the second row, I will replace it by multiply the third row by 4. So even if I multiply the 0 by 4, that would still be 0. And then if I add it here, it remains the same. So you have 0, 1. Now, but here, if I multiply this by 4 and add it here, I obtain 0. Multiply 4 to negative 1 and then add it to 6, I obtain 2. Then you copy the third row, 0, 0, 1, negative 1. Now next is to make this equal to 0. So for this entry to be equal to 0, you will have to replace the first row by the difference of the first row and the third row. So you have R1 minus R3. So you have 1. So 1 minus 0 is 1. And then negative 2 minus 0 is still negative 2. Now 1 minus 1 is 0. And then 0 minus negative 1 is positive 1. And then you copy the rest. 0, 1, 0, 2, 0, 0, 1, negative 1. Now, as the final step, we want this to be 0. How do you make this equal to 0? You would replace your row 1 by, you multiply row 2 by 2 and then add that to row 1. So it's row 1 plus 2 times row 2. So you have 2 times row 2. So 2 times 0 is still 0. Add that to row 1 is 1. Now, 2 times 1 is 2. Add that to negative 2, it's 0. And then this one is still 0, so it's 0. Now, 2 times 2 is 4, and then add that to 1, which is 5. And then you copy the rest. 0, 1, 0, 2, 0, 0, 1, negative 1. Now, we are able to obtain the reduced row echelon form of the augmented matrix. Now, this reduced row echelon form will give us the solution to the system of linear equations. So this one means that x is equal to 5, y is equal to 2, and z is equal to negative 1. So z is equal to negative 1. So the solution, that's the solution. So we can write the solution as the ordered triple. So we have a unique solution here given by 5 to negative 1.